Well, students, we have already discussed in my previous lecture about the sprayers and dusters. Now, we will go into some more details of how to design and how to select plant protection equipment, keeping in view the requirement of the crop, requirement of the situation, and the other parameters which are there at the hand of the designer. So, see the chemical tank, as I said, this is the first item which is to be there. Now, how what should be the capacity of this? How do you get the capacity of this? Well, it will depend on certain aspects, whether you are talking of a power source. What is the power source? If the power source is manual, then what will happen? If the power source is mechanical, then what will happen, and what should be the size? This is what is important. Now, how do you get this capacity? See, the actual capacity is generally 5 to 15% more than the required capacity to ensure there is always liquid for agitation. Now, you see sometimes when the agitator is there, it will keep that the liquid which we have created is in the right composition. It should not be that the particles settle down and then water is there on the top. No. So, there should be the agitation should be sufficient. So, in order that this happens, actual capacity should be 5 to 15% more. Now, we need to know what is the capacity of the tank. So, for knowing the capacity of the tank, it is very simple. You do not require such big mechanics for that. You should know what is the length of the plot that you have at your disposal and what is the width of coverage which you want to do. So, if you know these two things, the application rate is known to you, because depending upon the infestation or depending upon the earlier data that you have, you will utilize this. And once this is there, you can get this formula. This is very simple. You can just multiply this. This will be in the area. This is the application rate in liquid, liters per hectare. So, with this area got, you are getting actually liters, or you can get into meter cube. Here it will be in meter cube, because we have given the units accordingly, and that is why it is 10 to the power minus 7. So, the capacity of the tank can be known. Now, what is the material of the tank? See, you know that these materials could be corrosive. So, it will finish, or virtually the tank will not last long. So, we have to be very careful about the material of construction of the tank which is thought of. Generally, aluminum is one which is fair enough, then galvanized steel which is used, stainless steel and polyethylene plastics are commonly used for construction of spray tanks. Yes, these are ones which are used, and we find that these plastics are coming up in a big way, particularly with regard to the weight as well as non-corrosive. So, these are ones which are coming up. You do require a technology for creating those big tanks of plastic and all that, but that is now very much in use, and various types, in fact all the sprayers which you might have seen are all used of plastics. Hardly anybody uses aluminum or galvanized steel, but these are the materials one can use depending upon the situation, depending upon what he wants. So, these are the materials, and you can see that we have shown you this one which is there with us at IIT Kharagpur, which is of course a procured one, but then this is the one which we have for orchards. We are trying this, testing this for orchards. So, the capacity generally, or the types of for sprayers, the capacity generally for hand operated small sprayers could be 1 liter, could be 14 liter. Knapsack sprayers are 15 liters, 14 liters, 16 liters, sometimes depending on the size, and then tractor operated ones are 400 to 2500 liter capacity. Now, because once it is the power source which is very high, in that case then you can use this big ones, and ultimately it will you will be in a position to minimize the time for completing this particular operation. So, that is very important. Well, the heart of this particular sprayer is the pump here, because this is the one which is in fact delivering the energy for creating the droplets. Now, let us have a look at these, what are the different types of the pumps which are used, and how they are constructed, what is the pressure which is required, and all these things. So, if generally you know that when you are talking of high pressure pumps, generally these high pressure pumps are piston pumps or plunger pumps or diaphragm pumps or rotary pumps. Now, there is the pressure you can see, we have talked of this pressure, but then it is worth mentioning here also. The operating pressure is varying from 4.1 to 5.5 megapascal or 600 to 800 psi. Then the flow rate is about 75 to 225 liter per minute. So, this much is the flow rate. Now, plunger pumps, high pressure applications as I said earlier. Then rotary pumps, well, slightly low pressure ones, maximum pressure goes between 1 to 3 megapascal and the flow rate is 19 to 114 liter per minute. Well, these are the informations which we are from the literature available and from the experience that we have observed in testing of various types of sprayers. The diaphragm ones, also low sprayer ones, and these have about 3.4 megapascal up to this and up to 90 to 23 liter per minute of these are sometimes these diaphragm ones are better for particularly for abrasive materials, you can use them. Now, each has its own requirement and each has its own uniqueness, particularly with regards to use. So, we can see that what are these piston pumps. The piston pumps are very simple ones. You have seen all the pumps which we are used for our water lifting and all that. They are all piston pumps, okay, or plunger pumps. So, you can see here that this is the plunger here, and inside this pump, this is the one which when it goes here, you can see that suction will take place from this location here, and the liquid will be just discharged from here. So, now these are the valves which are closed. Once you pull it, the suction is created, vacuum is created, then the liquid will be sucked in, and after the moment it is pressed, the valves will open, and the vent is created, the valves will open and the liquid will go through this here. Now, the diaphragm type, the diaphragm membrane is there. So, this is the membrane which is there, and then the inlet and outlet, very simple. You can see it covers from here, and because of the movement of this, you see here the movement of this diaphragm is to and fro. So, as it is moving inside, then it sucks in, and it moves the reverse direction, then it pushes out. So, during that pressure, see these check valves, these check valves are direction, check valves are only talking of unidirection, because here check valve is inlet one when it is only putting inside, the other one which is only for outside. So, these two check valves are the very simple type of diaphragm, and as I said, these are good for abrasive materials. Then rotary pumps are also low pumps, low pressure pumps, but then they are also positive displacement. Now, what is this positive displacement? Remember that it is not affected because of the pressure as such, the discharge, okay. But there are other pumps which are affected because of the pressure, which we call them non-positive displacement pumps. So, the rotary pumps, you can see here that these rotary pumps where there is a rollers are there, then the rotor is there, and PTO driven. Here is the inlet. Now, the moment see this rollers, they move to and fro. So, when they move to and fro, while moving inside, they suck in, and while pushing that, this particular rotor keeps on rotating. So, when it keeps on rotating, they will go to the location where the outlet is there, they will and deliver it. From the inlet point, they will be sucked in. So, these rollers are moving to and fro, and then they do the job of suction and forcing it out. This is what is done in the rotary pumps. It's a very concept is very simple. If you open, you will be able to understand what are these. But as a designer, you must know what is happening inside the pump. Then only you will be able to change the pump. You will be able to design a new pump and see that the losses in the pump are lesser. And then you are in a position to choose a particular pump for a particular application part. So, these are the positive displacement pumps that we have talked of, the piston pumps, the rotary pumps, and the diaphragm pumps, and the pressures and volumes which are there. I have talked of these. Then let us know which are the non-positive and what is their behavior. See here the non-positive variable displacement pump, simple as that. The displacement will vary as the pressure. You can see here. You can see here that this centrifugal pump here. Now, see these pumps generally for high volume, and the essentially high speed ones, 3000 to 4000 rpm, and these are for low operating pressures. You can see that low operating pressures, but they are high volume and they are not suitable for high pressure applications. Of course, as I said, these are meant for but high volume, low pressure. Now, here you can see that the inlet is here. This is the location of the inlet here when it is sucked in, and this is the outlet here, and the impeller is here. So, this is sucked from here as the shaft is connected to the impeller. So, as the shaft rotates, the impeller is in a position to suck in, and then it is thrown from the periphery. You can see that this is how it is taken here, and then this is thrown out from this side. So, this is the way it will be thrown out, outlet. Now, these are why they are called a non-positive, because of the variable displacement. What is so variable? Here you see that when the pump speed is 6000 rpm, 4500 rpm, 2400 rpm, each case you see what is there. See, when you are plotting here pressure and this says pump outlet, you see here as the pressure, see 20 psi. If I say psi, well, please excuse me, because we have not changed the nomenclature of this which was given, because we have taken from the literature, and it is worth telling about exactly what they have given. So, you know that 1 psi is over 6.9 kPa. So, 1 psi is equal to 6.9 kilopascal. So, you can just know this. So, using this is of course gallon per minute here. This also 1 gallon, generally British gallon about 4.5 liters. So, 1 GPM gallon per, this is nothing but about 4.5 liter per minute. This can be taken. So, irrespective of the units that you are talking of, you can see for each of the speeds of these centrifugal pumps. See, as the pressure changes, increases here, there is a drop, on all these things. So, and although the volume handled by this is very high. So, the importance is that the volume handled is high, but they are affected because of the change in pressure. So, these are not used for constant and high pressure locations where it is required, where we are using the other pumps, as I discussed about piston pumps or plunger pumps, diaphragm pumps, rotary pumps, etc. Now, what is the power requirement in a pump? It is important. You should have how do you get the power source for running the pump, because pump is the heart. So, for that itself you need some energy, and that energy can be provided by the PTO of the tractor, or if you have an engine, or whatever is the power source that you can think of. So, how do you get the power? It is very simple. You can see the Q into P, where P is the Q is the flow rate and P is the pressure. So, once you know this, you are in a position to find out what is the power requirement of a particular pump. So, this is important so far as the different type of the non-positive displacement pumps are there. We had talked of positive displacement pumps, we had talked of non-positive displacement pumps. What else is there? Now, we are going ahead with the different components. You had seen, we had talked of the tank. Now, we are talking of the pump, and then we will talk about the droplets to be created, and so on and so forth. Let us go ahead. Preparation of spray solution. How do you prepare this spray solution? This is important. Sometimes you have the emulsions which are oil emulsion liquids, which are which need constant stirring, otherwise the solution will not remain colloidal throughout the process, and otherwise when you want to apply, you will find that the chemical is not actually in the same concentration which it should be there. So, you see here that many spray materials are suspension insoluble powders or emulsions. So, we need to have agitation system in that spray, whether mechanical or hydraulic, whatever. We need to have agitation. How do we do it? If it is a very large one and handling a large amount of chemical, then in the tank there has to be mechanism created. You can create that mechanism as it is said mechanical or hydraulic system. So, mechanical agitation employed for pressures above 2.5 megapascal. These are some of the informations which are given, and the lower pressure hydraulic agitators are employed. Well, these are some of the literature informations which are worth knowing, because then once as a designer, when you want to choose a particular type of agitation system, you should know what is the requirement and what is the device or what is the method which will be suitable for you, that you can take. So, when you are talking of mechanical agitators, well, in the mechanical agitators, what will be there in mechanical agitator? You definitely, this is the one. See, this particular, these are the paddles as shown here. These are the paddles. So, when this shaft rotates, and you can give power to this pulley here. So, when you will give power to this pulley, there will be rotation, and then these baffles will move inside. So, the size of the baffles, their diameter, etc., has to be very carefully chosen, and then for this you will require power for operation of these. Now, in the tank, now you can see that there should be a entry of here, and then there will be a screen for putting the chemical here. So, this where you will get the agitation from. Now, some of the information which is available in literature is worth mentioning to you. Empirical equations people have developed using these paddles. For example, they have used the minimum peripheral velocity of the paddles which are to be there, then the depth of liquid which is essential above the soft center line, it is important. Then the total R is the total combined width of paddles divided by tank length. See, these are some of the empirical equations. So, all these parameters have been taken into consideration. Then Fe is agitation factor, then Ps is the shaft input power, and L is the length of the tank. So, using these, then these are the two expressions which are available for you. So, minimum peripheral speed, how will you get the minimum peripheral speed? Then how will you get the shaft input power? Shaft input power at a particular given peripheral speed in kilowatt. So, these you have to use these. In fact, what is important, you have to be careful about the units of this. So, these are the proper units are to be definitely followed, then only these powers which are given here will be effective, otherwise they will not be effective and they will give a wrong value. So, when you are talking of the spray volume solution to be created, it has to be particularly for larger units, it has to be stirred or agitated over throughout the course of the application part, and it could be depending upon the it has been given a pressure is very high, above pressures, then where we will go for mechanical, and lower pressures slightly lower than that, maybe you can go for hydraulic one. Now, what do we do in these? In the mechanical one we have seen like this, in hydraulic system what we do. So, we will have what is there in this. See, in the hydraulic agitation, as it is said that is for low, slightly lower pressures as 2.1 megapascal in case of that, and lower pressures here. A portion of what is done, a portion of the pump's output is discharged into the spray tank. This is a beauty of this, that when the tank's output, a portion of that, maybe about say 10%, 15% of that is diverted back into the tank, and where it is diverted? Through a series of jet nozzles or orifices located in a pipe along the bottom of the tank. So, at the bottom of the tank, if you have small nozzles or orifices created, so bring back the output, certain portion of the output back into it. So, it will keep on delivering through these nozzles or the orifices at the bottom. So, each time there will be a rotation, I mean there will be stirring of the whole chemical, and that is why then you will be able to achieve that. Beauty of this is particularly this is good for the oil immersions, where if the mechanical ones will have the metal part and all that, the paddles. So, they may get deposited onto that. So, but this system is beautiful particularly for these emulsions. We have given some information, this table you can say table 1, this since we have picked up from there, table 1 say So, value of agitating factor. Now, I said you that what is this agitation factor. Now, that agitation factor has to be taken. This is the empirical information available from literature. So, it is worth mentioning here, and you should take up these depending upon the type of emulsion which is going to be used. You should take this thing, and then only you will be in a position to find out the emulsion and the wettable powder. For those, what is the amount of minimum total circulation rate that you will have to have, these are given. So, you can use this and find out the rates, minimum total circulation rates, and here is the hydraulic power. So, once in the hydraulic power, in order to find the hydraulic power, you will have to have QM, which is nothing but the minimum total circulation rate, and the pressure that you are talking of, pressure at the agitation nozzles. So, with these you will be in a position to find out what is the power, hydraulic power which will be required. So, if you are talking of the different selection and design of this, we have slowly we are coming from the tank, we are talking of the pump, then we are talking of the agitators in that system, and then we will talk of small you can say that droplets, how to create droplets, and definitely they will require some nozzles. So, what are all these? These nozzles or atomizers, yes, these nozzles are the ones which will create the atomization, which will create the smaller particles of the size which you want. So, the basic purpose of it is, I have already explained here. If you go through that, you will know the basic purpose of automation is to create as small as possible these the particles, which will then be virtually it will increase the surface area, and then when it gets deposited on the whole canopy, it will get spread here. So, with lesser amount, if you have better atomization or good amount of increase in surface area, that is what it is, in fact, increase the surface area of the liquid by breaking into many small droplets to cover the whole plant. So, this is the basic thing. Now, during atomization, energy is imparted to liquid to break into small particles, and by overcoming the surface tension, viscosity and inertia. Of course, these are the mechanics of it, the system which happens inside is given here. So, the atomization is important. How do you do it? You got to create pressure, you got to create circulation, you got to have the particular type of the nozzle which will give you that. So, but where should we keep the nozzles? We have also given this, I will come to this slightly later. Now, you talk of the different types of nozzles. What is there in the nozzle? See, the nozzles could be flat fan nozzles. That means, when the deposition takes place, it will be like this. You can see that the fan, just like a fan, if you have seen that flat fan nozzles, where the overlap now, spray pattern is flat sheet type. Now, the moment you have these, what is the level of overlap? Say, when you are talking of supposing the the solution comes through this, and then we have this arrangement or we have this arrangement here. So, there should be overlap in order that the uniformity is there. If you do not have, then there is a possibility that the spread which you get for coverage of all may not be sufficient enough, and that is why we need certain level of overlap. This overlap varies from as low as 15%, 20-25% to as high about 50% or so, depending upon the requirement, depending upon the type of nozzle you have used. So, here for spray angles 60 to 110 with 80 degree with the most common one. So, what is the spray angle? This angle, in fact, we are talking of this angle. So, when this angle, depending upon this angle which is over here, say 65 to 110, and with 80 being the most prominent which you use, you will get a overlap of 40% to obtain uniform coverage in case of a flat fan nozzle. In case of a flooding or this type of nozzle, you say that overlapping of patterns to obtain uniform coverage, 100% overlapping. This is different, because virtually you can see this is what happens. Spray angle is 100 to 150 degrees, and the operating pressure is 55 to 170 kPa or so. Here also 100 to 200 kPa. So, what happens in the automation? We are talking of having small particles, and then these particles actually once they are of a particular size, then we need to know where should be the overlap and what should be the angle of the spray which should be maintained of these nozzles. So, the angle has to be the spray angle has to be designed or selected, then the pressure has to be selected, and then only you can know what is the required overlap for getting uniform coverage. These are important when you are talking of the different types of nozzles. Well, hollow cone nozzles, sometimes we require that we do not want this to be there. So, we require hollow cone nozzles. So, you can see that this is the cone, a cone which is hollow inside. So, this is the type of pattern which you will find in case of a hollow cone nozzle, and the other details are very simple. The spray angle is varying from 60 to 95 degrees, the overlap is as say low 25% overlap, it is able to cover, and operating pressure is 270 to 550 kPa or so. Hollow conical sheet, as I said, this will look like this. Solid cone, well, it is hollow and that solid. You can see here that this is a solid cone. This will be required because then you want that this should happen, and this will be virtually covering the whole area. So, then you will have this. So, this will be overlap is a 25% overlap. Spray angle is about 130 degrees. Spray pattern is solid cone type, and the application pressure is this. The rotary nozzles, we have also talked of rotary nozzles. Controlled droplet atomizers, they are called as CDA. Then there are triple action nozzles, which are jet type, solid cone, hollow cone. They can produce 3 types of patterns. So, these are different types of nozzles which are used, and depending upon the requirement, these are very much used, and depending upon your requirement, you should select these nozzles. See, each and everything when we talk of design, the selection, proper selection is also design. It is not necessary that you will start fabricating, you will design each and every aspect, and then you will fabricate and then casting, etc., and then you will use. No, we are talking of what are the things which are minimum requirements, and correspondingly what is available in the market, which we have to choose for our system. So, that is why I have listed that this particular topic what we are discussing is selection and design. We will select the pumps, we will select the nozzles which are available depending upon our requirement, depending upon what sort of overlap I want, what is the crop which is there with me for to be sprayed and things like that. Select these nozzles, what are there in the nozzles? We thought that these are some things which we have and we wanted to show you. Many locations you may not find. So, it is worth showing you here that see the nozzle body, these are the nozzle body here, then swirl type, the swirling action takes place through these, then the washer or gasket is required for, so that there is not losses do not take place. Then orifice disc, there is an orifice disc which will help you to deliver that, and there is a cap for closing it. So, this is the details of the two nozzles which we have shown you. These are the smaller components which are there inside. Selection of these, how do you select? Well, I have discussed a lot about this. It will depend on the insecticides, fungicides or the herbicides. What is the chemical or what is the type and nature of the liquid or the powder, whatever it is to be done. So, if it is powder, we do not need these more nozzles, but definitely when a powder has to be made into a liquid and to be used. So, we have to think of depending on the application rate, crop spacing and operating pressure and speeds, you will have to select these nozzles, because these nozzles specifications are given that these are fit for what is the pressure ranges on which this should be worked. So, you should select that. What sometimes spurious design nozzles, and sometimes these are nozzles which are defective and not good quality ones, of course, particularly with regard to material and its life. Otherwise, you should be able to pick up these nozzles from the market and from good manufacturer who does this, reputed manufacturers who will have all these specifications, and he will also say what is the type of pump and what pressure you will definitely get and all that, and mention and the size of the particles which you will get. Nozzle materials, well, these different materials we start from aluminum, brass, stainless steel, ceramic, tungsten carbide. You will find brass and stainless steels are very commonly used of these you could see here. So, you will find that these materials are used for the atomizers. Design considered for nozzles or atomizers. What are the design considerations? What you are talking? So, you need to know how much is the velocity which will come out, so that you get the proper atomized particles of that size. So, this out of literature, the people which have researched and found out the empirical relationships between the various properties of the liquid, for example, the density of this, the viscosity of the material, the surface tension of that liquid, and what is the pressure at which and what sort of flow we want. So, depending upon all these parameters, then the empirical equations have been developed, and it is worth using these equations. It is not that one has to again start and do it for that, until unless there is a special requirement. You must use this and check how far is the is it from the reality. So, it is worth utilizing these. For example, you can see here that see here the jet diameter. This is the jet diameter dj. The Vj is the velocity of the jet, and rho is the density in kg per meter cube is this one. Then this is the viscosity. This should be greater than equal to 280 times this, where again you have rho here, which is the surface tension, and this is the density, this is the diameter, and this is viscosity. So, there is a relationship here, and then Vj talks of the jet velocity. So, this Vj is given by something like this, where delta P is the pressure and N is the turbulent flow, for 0.5 for turbulent flow. That talks of what type of flow will take place in the nozzle system when it is working. So, this is one available information about jet velocity for atomizers and nozzles, which can be used, which can be selected for our use. So, what are the different things that we have learned with regard to, particularly with regard to the flow rates, with regard to the nozzles, and with regard to the discharge of these nozzles, etc. See, we have the volume flow rate of these nozzles is given by this, where Vj is the we have seen it, our jet velocity, then A is the nozzle area and C is the area coefficient here. Then we are talking of what is this relationship between Ca and Cv, that is Cd is the discharge coefficient and Ca is area coefficient. So, discharge coefficient, area coefficient are related like this, where Cv is the one which we are talking of, the volume. Okay. So, using this, what we get here is Q is given by this formula, and then ultimately using these you get Vj to be given as Q by Cd into A, where A is the nozzle orifice area. Well, nozzle orifice area, so this has to be in meter square, because this is an area. So, you can see that average jet velocity may be computed from this particular equation. So, if you know these details, it is possible that you will be in a position to design a sprayer, and for a particular applications, the pump you can select with the pressure and the flow rate that you want, whether low volume, ultra low volume, high volume, etc., and the type of application, whether it is for orchards or wherever. So, with these information, I think it is worth knowing and selecting, etc., particularly with regard to sprayers. So, I think if you have further questions, we will definitely try to answer at the point of time when it is required, but I think this is suffice for the time being. Thank you.